Hello and welcome to another session in physics. In this session, we'll be looking at the topic conservation and transmission of energy. Conservation and transformation of energy. From our previous lesson, we've learned that energy is the capacity to do work. Energy is the ability to do work, which means without energy, it will be impossible to do work. So in other words, energy is directly proportional with work. They go hand in hand. They work together. It might interest you to know that energy can be converted from one form to another. You can convert energy from one form to another, especially in a closed system. It is because of this that we had to come up with a law that is called the law of conservation of energy, which states that in an enclosed system, energy cannot be created, nor can energy be destroyed, but energy can only be transformed from one form to another. We have so many examples of such energy conversions. Think of it, even the food we eat in our mouth, when we eat something like, let's say for instance, rice, at the end of the day, when you visit it is not the same rice that you excrete. You don't excrete the same rice, but you have to excrete what we call feces, and that is digested matter. That's what comes out. That is because this rice that you ate has undergone a process of metabolism. It has metabolized and it has broken down. It has been broken down by enzymes. The breaking down of this food you've eaten by enzymes is what we call chemical reactions. So it has been broken down from that rice you ate to the waste product, which is feces. Also in your body, when you drink water, some of this fluid hits your body in the form of sweat or urine. So the body helps to break down whatever it is that we put into it. In physics too, that is no exception, because energy is neither created nor is that energy destroyed, but the energy is transformed from one form to another. Examples of energy conversions include things like electric motor, converting electrical energy to mechanical energy. As you will spend time, a motor is a device, a special kind of generator that converts electrical energy to mechanical energy. On the other hand, for B, generator does the reverse of what an electrical motor does. Generator converts mechanical back to electrical energy. Some of us have bicycles, and at the back of our bicycle there is something that looks like this. There is something that looks like this. Then it helps to power a ball while this is being done. So while the bicycle is being pedaled, it causes the light in front of the bicycle to come on. This is a special kind of generator, not like the generator that you're used to, but this one is called a dynamo. It makes use of converting mechanical energy to electrical energy. The ones we know as the normal generators, the plants powering systems in our houses, they also make use of this dynamo to convert mechanical energy to electrical energy. That is why when you pull the rope of the generator, it causes startle inside the motor to start moving, and this starter cuts across what we call a rotor. Both of them combine together to convert that mechanical energy that has been created by the generator to electrical energy. And then we also have C, the special kind of conversion, the electric pressing iron that converts electrical energy to heat energy. You see, when you put on the generator in your house, so many things come to life. We have things like our TV, we have things like our radio, we have things like our pressing iron, we have things like our washing machine. We have things like our cooking stove. All of these things come to life. Even our phones are able to start charging. All this started from a single process, and that was the generator that we put on outside. The TV is called the television because when you look at it, you're able to see people moving. That picture is brought to you in the form of light energy. Now, this light energy did not just stem up from anywhere. It came from the generator that you started. That is why if there is no electricity and you walk into the house and you see the TV talking, you get scared, because you know under normal circumstances it is not possible for a TV to without electric energy or electricity. Also, for you to be able to press and iron your clothes, you need electrical energy as well. That electrical energy is going to come when the generator is started, or the electrical power distribution company is able to bring electricity to our homes, so we can make use of the electrical appliances in our various houses. So get that principle down once again, that energy can neither be created nor can energy be destroyed, but energy can only be transformed from one form to another. At this point, let's talk about world energy resources. When we talk about world energy resources, we're simply all the resources that we can find in the world around us. We have natural resources, we have mineral resources. There are so many resources. You think of things like gold, you think of things like silver, talk about things like diamond. I'm sure you must have heard about crude oil too. Crude oil. And then you hear about things like limestone. These are resources that we have in the world around us. Some of them we have to dig deep in the ground before we find them. Some of them we also find on the surface of the ground around us. These world energies are divided into two resources. Those two resources are renewable and non-renewable resources. Renewable and non-renewable resources. So, what do we mean when we talk about renewable resources? When we talk about renewable resources, we're simply referring to energy that can be replaced as they are used up. In other words, they don't get exhausted. They do not finish. For example, look at solar energy, energy from the sun. Has there ever been a day that you woke up and the sun ceased to exist, or you heard that the sun has finished, so to speak? The sun does not finish, because the solar energy that comes from the sun is a special kind of renewable energy resource. Itself as being used, it is inexhaustible. Another kind of energy that is inexhaustible is wind energy, and that is why we're able to breathe every day. We breathe oxygen, we feel the effects of wind. When we wash our clothes, we leave it to dry. Wind helps to dry our clothes as well. We feel the effects of wind. There has never been a day we woke up and they told us that the wind in the world has been exhausted or that it has finished. It is another example of renewable energy. And we have water energy. Water can never finish. In fact, scientists have discovered that about 70% of the surface of the earth is covered with water. So it's basically impossible for water to get finished in the world. We keep drinking and drinking and drinking. We have our oceans, we have our seas, we have our streams, we have our ponds and our lakes. All these are sources of water energy. They do not get finished. They do not get exhausted. And then we have biomass. Biomass energy that can be gotten from plants and decayed. As things continue to die and deteriorate, and as long as radioactivity exists, there will always be biomass. Biomass will always continue to exist. So energy from decayed matter will always continue to be there. Seasonally, we see trees that shed off their old leaves, spring up with new ones. these leaves that they shed off decay on the ground and help to constitute decayed matter, which can be used as biofuel or biomass. On the other hand, too, a second kind of world energy resource is non-renewable energy resource. As the name implies, non-renewable simply refers to energy that cannot be replaced after use. The key word is cannot. So the opposite of renewable energy resource is non-renewable energy resource. As we've used that up, it cannot be replaced again. Let's say, for instance, nuclear energy. Nuclear energy now, in the previous class, I talked about a process known as fusion and a process known as fission. This fusion and fission is the principle that is being used in the construction of atomic bombs. That is how atomic bombs operate. Now, when two or more heavy nuclei are made to degrade, they release a huge amount of energy. This huge amount of energy could come in the form of an explosion, could come in the form of heat, and that is how we have atomic weapons, weapons of mass destruction. So once an explosion occurs, that energy is gone for the meantime until another one is dead. And it goes against the law of conservation of energy, that it is neither created nor destroyed, but can only be transformed from one form to the other. Another is petroleum. Petroleum energy is a non-renewable energy resource. In fact, studies have shown that recently in some countries that were usually blessed with abundant sources of petroleum, such as crude oil, they've had that going down. The reason for this is because petroleum is a non-renewable energy resource. As it continues to be tapped and harnessed, it can actually get finished. In fact, petroleum is gotten from decades and aeons of years of dead, decayed matter that have been in existence for millions of years. We have what we call crude oil. That is how crude oil came into existence. So if a process that tampers with the decaying of this matter is established, then it means that the production of petroleum would actually come to a halt, and then other things like natural gas. So as you can see from the diagram here, you notice the renewable energy resources and you see the non-renewable energy resources by your right hand side. So that's all we have for the world energy resources. Thank you for joining us in this lesson, and to refresh your memory on what we've just discussed, please take the test that will soon appear on your screen.